Alright, today we're going to take a look at Chapter 4, Section 4 on Scientific Notation. So if you have your workbook, we're going to start here. Let's see, I believe this is on page 79 in your workbook. Otherwise, if you don't have it with you, you can just follow along with us. So the first part here is getting started. We're going to skip that for just a minute, and let's go ahead and jump into the real world link. Alright? So this part says Earth is the third planet from the Sun in our solar system, and because the Earth's rotation about the Sun is not circular, it's actually more of an ellipse, squished oval, the maximum distance between Earth and the Sun is about 95 million miles, and the minimum distance is about 91 million miles. So they're asking us, write 91 million using numbers. So 91 million. I'm going to make sure that this is on, let's use blue. So 91 million would just be, or purple, 91,000,000, right? So 1,000 million, 91 million. So now they're asking us, what is the value of 9.1 times 10? And then 9.1 times 100. So 9.1 times 10, we move the decimal over once when we multiply, right? Times 10. So times 10 would be moving it over once, so the answer would be 91. Now, if we switch colors, and I'm going to move myself out of the way here, maybe I can get to the controls a little easier. So if I switch colors, the next one, 91 times 100, we would move that decimal over once, over twice. So the second answer would be 9100. So 9,000, wait, times 100. I think I did too many. There, 910, right? 9.1 times 10 times 100. There we go. So 9.1 times 10 is 91. 9.1 times 100 is 910. Okay, so we're using the same process to fill out this table here. So they're giving us, well, we just did the first one, right? Times 10 is 91. Times 100 is 910, so 900. Times 1,000, I would bet, is 2 zeros. And I would bet here we keep going. So do you see 3 zeros here? So we're going to do 1, 2, 3, 4. So this means we would move this decimal place over once. So over once, let me see here, times 10, times 100, times 1,000, times 10,000. So times 10, times 100, times 1,000, times 100,000, 10,000. So we'd say, that's just me counting out how many spaces to move it. So 91000. The decimal was originally here, and we're moving this 1, 2, 3, 4 spots, right? So 1, 2, 3, 4 spots. So this one, I would bet that this is going to have 5 zeros. So we're going to take 9, there was here, we're going to do, move it over 1, 2, 3, 4, 5 spots. So we're moving the decimal 5 spots, which ends up giving us 4 zeros. Let's do another one. So 6 zeros. 1, 2, 3, 4, 5, 6. So 6 zeros. So we're going to move this over 6 spots. The decimal was here. We're going to move over 6 spots. 1, 2, 3, 4, 5, 6 spots. And the decimal would come at the end. It would be at the end on each of these if you wanted to put a decimal in. Oh my goodness. 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that means this, it was originally 9.1, so we're going to take that decimal. I don't want to actually include the decimal in there. So 9.1, so we're moving that decimal over 1, 2, 3, 4, 5, 6, 7 spots. Gosh. So these are commas. 91 million. Wow. So what they're asking now, it says multiplying 9.1 by what number results in the original? Well, 9.1 by what number? The original number was 9.1, so you could say by 1. So times 1 gives you the original number, but we've been doing all kinds of, yeah, I think it's just 1. Maybe that's it. Let's just leave it. Times 1. Number 5 says, what is this number written as a power of 10? How can you get the number 1 to appear if you're using a power of 10? Let's try a few things in a calculator. So if you grab a calculator and you say 10 to what power, right? So what we're going to do is we're going to say 10 to what power? We need to fill in the box. So what can we put here? If you say 10 to the first power, that gives you 10. Try it out in your calculator. 10 to the first power. It gives you 10. So we need something smaller than that. Well, what's smaller than 1? What's smaller than 1? In fact, it's a 0. If you try this in your calculator, 10 to the 0 power, so you would type in 10 caret 0, and that should give you a 1. So anything to the 0 power gives you 1. You could type in 365 to the 0 power, and it gives you 1. This works every time. Fun fact for your day. Let's look at number 6. So number 6 is saying, how could you rewrite 91 million? That was this big guy at the end. This one. How could you write 91 million as the product of a number in the power of 10? Well, let's start with the original number they gave us in a power of 10. 9.1, a power of 10. Okay? So let's see. 10 to the first power is 10, right? 10 to the first power gives us 10. 10 to the second power gives us 100. And then, I'm going to keep going. 10 to the third power gives us 1,000. Can you see how many zeros there are? The number of zeros is the same as the exponent. How many zeros does this guy have? 1, 2, 3, 4, 5, 6, 7. So we put a 7 in there. That tells us where that place value is. So times 10 to the 7th. So number 7 asks us the next question. Based on your answer to the thing we just did, what is 95 million written as the product? What is 95 million written as the product of a number and a power of 10? Didn't we just do that? 95 million. Okay, sorry. I was trying to figure out how those numbers were different. 91 million and 95 million. Wouldn't that be the same thing except with a 0.5 instead of a 0.1? That seemed too easy. Okay. Let's go on to the next page. That was suspiciously easy. So this one's asking us here. I'm going to scroll here. Circle each number below that is written in scientific notation. So here's our rule for scientific notation. So you have to have one number, one digit in front of the decimal. So we're going to say here you have to have a non-zero number, and then the decimal place, and then you can have extra stuff if you want to, but you don't have to. And then it has to be times 10 to a power, okay? So that's scientific notation. So it has to have a non-zero number. You can't say 0.5 times 10 to the first. That's nice. The 0 out in front makes that incorrect scientific notation. It's still a number. You can use it in problems, whatever, but it is not scientific notation. You could do 3.7 times 10 to the 48th power, or you could do 0.2 times 10 to the negative second. That doesn't work because it's a 0. What about like 43 times 10 to the negative second? You could not do that because there's two numbers out in front, so that's wrong also. It has to have only one digit in front of the decimal, okay? So let's go through these practice problems. Let's see if we can identify which are okay and which are not. So these first ones here, that has a 0 out in front, right? Not it. That one's only got one digit, so that one works. That one's got one digit, so that works. Do you see how this one's a negative exponent and this one's a positive? That's okay. They're both scientific notation. That one's got one digit, so that works. This one has a bunch afterwards, but that's okay. It doesn't matter. Ooh, 2 here. Nope. This one's good. How about this one? That one's good. This one, ooh, it's got a 0. Nope. And this one's good. So you can have anything from no decimal place to a bunch of decimal places. that doesn't matter, but there has to be one non-zero out in front. Okay, so the next part's asking us to write these in standard form, then order from least to greatest. I would pause right now, see if you can do these, and then I'll work through these here. If you hit play again, I'll work through them with you. So this first one's asking here, write this from least, okay, standard form. So we're going to take this number here in standard form. It says times 10 to the fifth, so we're going to take this decimal, move this to the right 5 spots. Make this bigger, 5 spots. 1, 2, 3, 4, 5. Because, isn't 10 to the fifth, think about that. 10 to the fifth is 10 times 10 times 10 times 10 times 10. That's a big number. 1, 2, 3, 4, 5. That's a big number. That's this guy. So 4 times this gives you a really big value. So here it makes sense that this is going to get larger. So we're going to say 4. The decimal was here. We're going to move it over 5 spots. So 1, 2, 3, 4, 5 spots. This one's already written in standard form, so I'm going to copy that. This one, 3 times 10 to the fifth, so I'm going to write the 3. The decimal would be here. We're going to go right 5 spots. 1, 2, 3, 4, 5. The next one, 1.3 times 10 to the 5, so I'm going to write the decimal would be here. We're going to move right 5 spots. 1, 2, 3, 4, 5. You don't have to put the decimal at the end. If you want to, you can. This one's a comma, not a decimal. So now we have to go least to greatest, all right? So if we go least to greatest, which one's smallest? I think this one's smallest, right? 1, 2, 3, 4, 5. Ooh, this one's smallest. So we're going to type in, or I'm going to write 1, 3, 0, 0, 0, 0. The next one would be this guy. 3, 0, 0. And actually, what we can do, instead of writing these, I'm going to write this, so this would be first. 1.3 times 10 to the fifth. And then the next smallest was this one, 3 times 10 to the fifth. Next would be, which one of these is smaller? Isn't this one smaller? 4.05 times 10 to the fifth. And the last one would be 420,000. Okay. Let's do the next one. So, next one's asking us here, least to greatest. Okay, so I'm going to go back to red here. This one's already in standard form, so let's look at this one. The decimal would be after the 2. In this case, we're going to go this way since it's got a negative exponent. So the decimal's going to go 1, 2 spots. This is the new place for the decimal. So this becomes 0.02. And this one becomes, this is positive exponent, so we're going this way, 3.1. We're going to take this decimal, 1, 2, 3 spots, fill in zeros. I can delete this decimal. Alright, and now we're supposed to order from least to greatest. These are already in standard form. So we're supposed to go from least to greatest. The smallest value, we've got 0.02 and 0.029. I think 0.02 would be smaller. Ooh, but we have this guy. More zeros. Let's do that one first. 0.0024. Next, we're going to do this guy, 0.02. And then 0.029. And then this guy, which would be 3.1 times 10 to the third. Okay. How do you compare scientific numbers in scientific notation? I'm going to say look at exponent. So the smallest exponent would go at the small end. Largest exponent, positive number, would be the biggest. You can also put it into scientific or standard notation, write the numbers out to compare as well. Look at the exponent to help first. Okay, that summarizes this lesson. I know I went quick, so please ask questions if you have any, email anytime, and then see our Google Classroom for our assignment from section Scientific Notation, Section 4. Okay, good luck.